Hi guys, good morning, good evening and good afternoon. Good morning, good afternoon and good evening. I hope you had your breakfast, lunch or dinner, whatever you had. Just sit back and let's start our discussion. In the previous session, we discussed about the explanation of hydrogen atomic spectra based on Bohr's atomic model. I hope you gone through it. You have raised your doubt in the portal. I'll be solving it immediately once you have raised it down. Whatever be the doubt, just raise it there. That is the only way I can communicate to you, unfortunately. So please bear with me. Whatever doubt arises under the sky, you write it down in the portal. I'll be able to help you. Whatever out of scope also, we'll try to solve. And once hope you come to college, we'll be able to discuss it in detail. Then, yeah, and please be safe. Stay inside home. Don't roam around a lot. And what is that? Along with corona, you have this bad weather that may make you sick any point of time. So please be safe and be healthy. Eat whatever be the kind of food that is prepared by your mom. You try to learn some cooking, it would be helpful for you. Now back to chemistry. We were discussing about the explanation of Bohr's atomic model, Bohr's atomic model, then about the hydrogen spectra, how Bohr used his atomic model to explain hydrogen spectra. He told that in an atom, nucleus is there, and around the nucleus orbits are there, fixed path, electron will be there in the orbit. So when an electron absorbs energy, when an atom absorbs energy, some of the energy is transferred to the electron, it absorbs energy, it will have higher energy, it means it will have a higher excited state, it will stay in the excited state for a maximum of 10 to the power minus 8 seconds, then it moves down to any of the energy levels. Whenever the de-excitation takes place, one wave is emitted, and the emitted wave will have energy corresponding to the difference in energy level. If the difference in energy is large between the two levels, de-excitation, then amount of energy emitted, the radiation emitted will have higher energy, lower wavelength. Or if the amount of energy released is less, the wave that is emitted during the de-excitation will have lower energy and higher wavelength. That is what he used to explain the concept of hydrogen spectra and different series. If the electron is getting de-excited to first energy level from anywhere else, even from infinity, you call it as Lyman, second energy level of atom, Balmer, Paschen, bracket and fun. And I gave you expression to calculate wave number, frequency and wavelength. Really important questions would be asked, and we discussed numerical also. So this is points that we discussed yesterday, correct? And then I gave you a different expression. I'm not going to write it now again. I gave you different expressions to calculate wave number, frequency and wavelength for hydrogen like species. This is applicable. Bohr's atomic model is only applicable for hydrogen like species. Then I gave you different kinds of spectra. You have to draw the energy lines, correct? And here also I gave you one line, don't forget, where you have to write energy, increasing order of energy, 1, 2, 3, 4, 5, 6, 7 up to infinity. You don't need to write the excitation, but you have to write the de-excitation, and it should end in an arrow. One set Lyman, another set Balmer. You don't need to draw this. You don't need to draw this when you draw in your for your exam. Third set, all the lines should come to n equals 3. Then fourth, fifth, Lyman, Balmer, what is the Lyman, Balmer, Paschen, bracket and fun. That's it. You will get 3 to 4 marks surely for this question. You are good in drawing, so don't waste mark. Try to understand it clearly how it goes. You have enough time. So now if you study, it would be useful for any of your exams. So this is how he explained, whenever an electron is undergoing de-excitation, it emits a wave. This is lower energy, high wavelength, this is higher energy, low wavelength, and then I told you what are the different regions. So this also you write it down when they ask you for your when they ask you for your 4 marks. This also you have to write. You have to write series, where it is coming. Even if you don't write this, no problem, but you have to write the list. What does N2 stand for? What does N1 stand for? Any higher energy level is N2. I told you what is a limiting line. Any line that is coming from infinity to any of the lower energy level, you call it as limiting line, correct? Then how to calculate number of transition N2 minus N1 into N2 minus N1 plus 1 divided by 2. That also we discuss. Then we discuss the numerical. I forgot to discuss one numerical that we will be discussing today, that is 2.23. This we will discuss in today's session. Now moving back to structure of atom, session 10, correct? In this one, please be ready to listen something which does not have a clear basic for you, because there is a basic, but that basic they have not included in NCERT. So it looks weird, you may have some doubts, you ask the doubts, we will be able to solve, but if it is out of scope, you don't need to worry about that. Sir, why did this come, how did this happen? I will try to explain in a simple way, basics, so that you will able to understand it in some way, but you need to remember it, that is it. There are certain things in NCERT which they have connected to something else without any base, that is only this part, you call it as quantum mechanical model. We will deal with it, we will discuss it, don't worry, with example I will try to explain. Now the next model, see, last class I told you about demerits of Bohr's atomic model, correct, demerits of, please refer to it. Bohr's atomic model was applicable only for hydrogen. I will tell you advantages of Bohr's atomic model. It was applicable for hydrogen like species that contains only one electron, correct. It gave expressions for energy, wave number, what is that, energy radius and velocity was able to be calculated, but it has a lot of drawbacks, different drawbacks. You remember, it is a flat or two-dimensional model, then it cannot explain the fine spectrum. I told you each line is actually a combination of different thin lines, fine spectrum they call it as. Then it couldn't explain what is Zeeman effect. Please remember, 1 mark question, what is Zeeman effect? Splitting of splitting of lines in presence of magnetic field, splitting of line spectra in presence of magnetic field is known as Zeeman effect, and in presence of electric field is known as Stark effect. 1 mark question. Then he could not explain it, he could not explain the nature of bonding, why atoms combine, how do atoms combine to form chemical bond, ionic bond, covalent bond. Based on his theory, it was not able to be explained, how does that happen. Then new theories were put forward by scientists known as de Broglie and uncertainty principle. All these were drawbacks of Rutherford atomic model. So now the Bohr's atomic model, and Bohr's atomic model is kept aside, it is not completely shelved, but some of the concept from Bohr's atomic model was used, and a new atomic model known as quantum mechanical model. You know quanta, if you remember quanta, what is quanta? It came from Planck's quantum theory. Quanta means photon, quantization, fixed value. Quantum mechanical model of atom. See, one thing you have to keep in mind is that day by day new discoveries are made. The dish what you are eating now, that I will tell you fairly best example, the dish that you are eating now, you have a lot of dish, Chinese dish, variety of Indian dishes, Mexican dish have been introduced, Indo-Mexican varieties are there. Old times such dishes were not there, correct, because they never thought of that, but now people are thinking outside the box, you call them as outside the box, understood. See, now online classes, who thought online classes will be happening, your parents might not have, even you might, even I didn't think that such kind of things will be happening. So as the advent of technology, new sophisticated instruments were developed, people started thinking differently, so that made them to think, why can't this be the structure of the atom? Based on that, some scientists collaborated and contributed to a new structure of atom, and that is known as I'm sorry that sorry, no, just cough, don't worry. That is known as quantum mechanical model of atom, Now, before going to quantum mechanical model of atom, there are two main things you need to remember with respect to quantum mechanical model of atom. One is known as de Broglie equation. It's a French scientist, Louis de Broglie. His name is Louis de Broglie, and he gave a concept. I'll explain you the concept. Now, let's go back to electromagnetic wave theory. According to electromagnetic wave theory, light travels in the form of waves, correct? So I repeat again, according to electromagnetic wave theory, light travels in the form of waves, correct? So I write here, light travel. So light have one property, that is wave like nature, means it will exhibit the properties like diffraction and interference. It will exhibit the properties like, I explain what is diffraction and interference. These are the two properties of light that explains that it has wave like nature. Even you can say shadow, creating shadow, but you cannot use the term here. So light has wave like nature because light gives diffraction pattern and also it exhibits a property like interference, and these two properties are exhibited by those things that behaves like waves. So light behaves as waves. Also, according to Planck's quantum theory, PQT I am writing, Planck's quantum theory, light behaves as a particle. It means it has a mass. We know that mass is not that, but still it behaves as particle, and that was explained by photoelectric effect. I will explain it. And also black body radiation, BBR. Now imagine photoelectric effect, how Planck's quantum theory can be used to explain that light has mass. I will tell you. Imagine you have a photographic plate, light falls on it, light falls on you, correct? Now obviously you are strong, light does not make any light just pass through it, or it gets reflected or scattered, etc., etc., etc. Now when light falls on the surface, when light hits the surface, what exactly it is doing? It is converting its energy into the kinetic energy of photoelectron. It means there is an interaction between light and matter, correct? If light is behaving just as a wave, it will just hit the surface and either it get reflected or it get penetrated. So if light has only wave nature, I repeat again, if light has only wave nature, it will not knock out the electron, because there is a transfer of energy, mass. If something is coming and hitting me, correct, if it has mass, then only I will feel the hit. If light is passing through me, it does not have mass with respect to me, but no, atom is a small particle. So when light hits the surface of atom, it knocks out an electron. It means it has punch, it has energy that is related to mass. You call it as mass equivalence. Use the term mass equivalence of a photon, mass equivalence of a photon based on E equals mc squared, correct? So it means light when hits a metal surface, it hits in such a way that it behaves like it has mass, so that it will transfer its energy into kinetic energy of photoelectron. So photoelectric effect, similarly black body radiation, you studied black body radiation is also a concept that went against electromagnetic theory, correct? So these two phenomena explains that light has two properties. One is known as wave like nature, other is particle nature. So hence you call it as light behave as dual nature, or light has dual nature. You know what is dual nature? Two characters, like if you have seen the movie Onion, Hindi, or I don't know how you call it, Kannada, the movie, in that movie he has two characters, three characters. Understood? So same way light behaves as two characters. Light has two properties. One is wave like nature and other is particle nature. Hence you say it's a dual nature of light. Dual nature of light. So this is an example. So electromagnetic wave theory says that light has wave like nature. Planck's quantum theory explains that it has particle nature, which is given example of black body radiation and photoelectric effect. So together light exhibits wave nature and particle nature, while light exhibits wave nature and particle nature. So you call it as dual nature of light, correct? Now that is, here it is given dual nature of matter. I will explain. Similarly, now you think of electron. Does electron has mass? Obviously has mass. It means electron behaves as a particle. I hope all of you know anything that has mass and space, it's a matter. Matter is nothing but a particle. So electron has particle nature. Correct? Because it's a matter. Correct? No. Now they also observed that electron could exhibit diffraction. Electron is also, there is an instrument known as electron microscope. No, it is out of scope, just I am telling you an example. There is something known as electron, you know what is microscope, right? Same way there is an electron microscope which creates, there is a scientist known as Grigor. They found that electron also exhibit the property of diffraction. Now which substance exhibit the property of diffraction? Waves. Diffraction is a property exhibited by wave. It means along with particle nature, electrons also have wave nature. So I repeat again, electron has mass, it means it has particle nature. Along with that they also observed, electrons also travel in the form of a wave because it exhibits the property of diffraction. Diffraction is bending of waves when they hit opaque object, that is known as diffraction in simple terms, correct. So electron also exhibit the property of diffraction, it means it also has wave nature. So particle nature of electron coupled with wave nature of electron, you can also say, what is that? Electron also exhibits dual nature. So just like light exhibits both property of an wave and particle, similarly electron also exhibit the property of particle nature and wave nature, hence it exhibits dual natures. That is known as dual nature of matter, because electron is a matter, correct. And the scientist who found it was, his name was de Broglie. His name was de Broglie. He was a person who gave the explanation that electron exhibits diffraction, it means it should behave as a wave, also it has mass, so it behaves as a particle. So hence electron behaves as a, or electron has dual nature, multiple character, one is wave nature and also particle nature. That is known as dual nature of electron. As electron is a matter, you call it as dual nature of matter. Electron is a matter. It means if electron is coming from any source, how will it will travel? If electron is coming from any source, electron will travel in the form of wave. This is known as dual nature of electron. I hope it is clear. So light exhibits property of wave and particle, dual nature of light. Similarly electron was also exhibit, different experiments are there. Electron also exhibit the property of particle nature and also wave nature. So we can say electron also has dual nature, you call it as dual nature of matter because electron is a matter, correct. So hence de Broglie said electron is a matter wave. Now what is a matter wave? Any object, any particle that has two properties. What is that? Material nature and wave nature. So a matter wave is any object that has two characteristics. What are the two characteristics? Material nature and wave-like nature. Material nature and wave-like nature. Such objects or such property is known as matter wave. So it's a property that is exhibited by certain objects, certain substances, usually subatomic particles, whose mass is very less, especially electron. So electron is a matter wave. So if I say electron is a matter wave, what should I mean? What would I mean? What am I meaning? It says that electron has two characteristics. Electron, if I say electron has matter wave, so it means it's a material substance that exhibits wave property. Is it clear? So electron is a material substance, it's a particle that exhibits wave property. Hence you can call electron as a matter wave. Electron as a, I hope you understood. So I repeat again, light was supposed to exhibit wave nature based on its diffraction and interference explained by electromagnetic wave theory. Planck's quantum theory said as light exhibits photoelectric effect, it should also have particle nature. Based on this, they said that light exhibits dual nature, that is particle nature and wave nature. So you can say light is a matter wave, correct. Similarly, later on other scientists discovered that electron could exhibit the phenomenon of diffraction, which is only exhibited by a wave. Hence electron also has wave-like nature. Obviously electron has mass, it's a material particle, also wave nature. Together electron exhibits dual character, correct. So it has mass and it will travel in the form of a wave. Hence electron is said to exhibit, or electron is said to be a matter wave. Electron is said to be a matter wave. It is clear? I hope it is clear. Please go through it, listen to it again. So electron exhibits both characteristics, material nature and wave nature. So electron is a matter wave, and that explanation is given by de Broglie, correct. So that is known as dual nature of matter and the concept of matter wave. So matter wave means any particle, they said not only electron, all subatomic particles are matter waves. Why? Because they have very less mass and also they tend to travel in the form of a wave, explained by experiments. Correct? Please note it down in your notebook. So, if I am telling you to write in a notebook, please write it down like this, because this they will not ask you for boards, but just for your understanding. Okay. So, first you can write light exhibits two characteristics, electron exhibits two characteristics, this thing, and then this one, which was given by a scientist known as de Broglie. Okay. Now, so that is about the dual nature of matter. See, I will tell you one more thing, best example. It is not only electron, even they say that we travel in the form of waves, but if I am walking like this, imagine I am walking straight to you. Do you think I am traveling in the form of wave? If a person is drunk, obviously he will travel in the form of a wave. I hope all of you know, drunk person, right? He will not walk straight. Sometimes he will go here, then he will go here, then he will go here. He might be traveling in the form of wave, but that is different. That is different story. Now, take a feather whose mass is say 1 milligram. Feather whose mass is 1 milligram. Take your case, who is around 60, 70, 80 gram. Sorry, not gram, kilogram. Compare your movement and the movement of the feather. Feather moves slowly. If you see feather moving, it's like not a wave, but still slowly it moves, which is in the milligram scale. You are walking straight, you are not moving in the form of a wave. So, you decrease the wave. If feather can move very slowly like this, think of an electron. Electron will be moving very slowly, aram se, and it moves in the form of a wave. So, even though they say we are also matter waves, but the wave created by us is very less. But electron is a matter wave, and you know the concept of matter wave. Now, to explain it further, de Broglie gave an equation. I will help you to derive the expression. Correct? I will help you to derive the expression. Write it in your notebook. Correct? So, derivation of de Broglie equation. You need only the final equation, but you need to know how it is derived. Now, electron or any subatomic particle or any matter wave has two nature. One is particle nature, other is known as wave nature. Wave nature. So, one is particle nature, other is wave nature. Now, you know Einstein's theory, E equals mc squared, that has mass. If it behaves as a particle nature, like particle mass, correct, then you can use energy of any particle traveling with a velocity that of light. If it is traveling with respect to light, E is equal to mc squared. At the same time, if it has wave nature, Planck's quantum theory, energy of a wave, correct, what is energy of a wave? E is equal to hc by lambda. If it is a dual nature, both the energy will be same. If I write E and E dash, it would be E would be equal to E dash, because it is a matter wave. It should have both characteristics. This energy and this energy should be same, because if it is mass, it is E is equal to mc squared, and if it is a wave, E equals hc by lambda. So, equate both of it, then I can write mc squared is equal to hc by lambda. This and this will get cancelled. So, what do I have? Lambda equals h by, I will just replace c with v, that is velocity, because it is not compulsory that electron will travel in the velocity of light. No, less than that of light. I told you on that day, electronic speed is 1 in the first orbit is 1% to that of light, less than that of light. So, c, we know c is velocity of light, but I can replace it with the term v, velocity. So, instead of that I can write lambda equals h by mv, correct. So, this is one expression for de Broglie. This is known as de Broglie equation. Also keep in mind, where mass is, m is mass, v is velocity of the particle, correct. Now m into v is p, where p stands for momentum. I hope all of you know we had told about linear momentum. Linear momentum means any objects traveling in a straight line that has mass and velocity, you say it has momentum, linear momentum traveling in a line. So m into v is also p, which is known as momentum, linear momentum. So this equation can also be written as lambda equals h by p. This is another equation. So I repeat again, E, energy of the particle, m, mass of the particle, velocity of light, correct. This c, velocity, wavelength of the wave, of the matter wave. When you equate, E equal to mc squared, it's c by lambda, c and c will get cancelled. I should get lambda equals h by mc, but we are talking about an electron, correct. If we are talking about electron, we can use the term velocity v instead of c. So lambda equals h by mv, where h is Planck's constant. Now mass into velocity is known as momentum, given as p. So we have lambda equals h by p or lambda equals h by mv. Now this is the way how you, where m is mass of electron. You see, what is lambda? It's a wave characteristics. What is mass? It is a characteristic of a particle. In this equation you have two characteristics, one is wave characteristic and material, mass, particle characteristics. Hence this is applicable for any object or any subatomic particle. Even for us, I will tell you example which has a wavelength lambda and has mass. Now that is first expression, don't write now. One more, relation between kinetic energy and wavelength of the matter wave. If it has mass and velocity, it should have kinetic energy, correct. Now kinetic energy, so this is electron or any matter wave, correct. Now kinetic energy is given as half mv squared, Now we know that lambda equals h by mv, correct. No, or I can write v equals h by lambda into p, sorry not p, lambda into v, lambda into m. V will go here, lambda will come here, correct. Now you substitute this v in equation 1. So what will you get? Kinetic energy, I will just write kinetic energy is equal to half into m into this over here, h by m into lambda the whole square, correct, which can also be written as half into m into h squared by m squared lambda square, correct. This square and this m will get cancelled. So I will have half into h squared by m into lambda square. This is one expression. But if I need lambda square is what? H squared by 2 into m into kinetic energy or energy. Now this is square, so therefore lambda is equal to h by h square, you will get square root, correct, square root of this, square root of 2 into m into kinetic energy. So this is the expression. Numerical will be asked. So this relation gives you, so here this relation gives a wavelength of a matter wave that has wavelength and mass and velocity, or wavelength and momentum. correct, and this relation gives you the relation between, this equation gives you the relation between wavelength and kinetic energy of the subatomic particle, correct. Please write this down along with this one in your notebook. It can be applicable for any particle, we will use our weight also, not us, but we have taken, I have taken an example. So, this is particle nature, E equals mc square, wave nature, energy, and if it is a matter wave, both the energy will be one and the same with respect to particle and wave. Equate, you have an equation, that equation would be relation for a matter wave that exhibits wave nature and a particle nature, lambda equals h by p. Then its energy. Energy can be in joules or also it can be in volts. M, it can be a mass of electron, mass of anything, I will take an example. C can be even velocity, if they say velocity of light, but usually not velocity of light, less than that. Okay. Now let us go for next example. I have taken, okay, before going into it, I have an example. Okay. Now let us calculate the wavelength of two particles. I think I have given a question over here. Okay, leave it. Let us take an example. I will give you an example. Imagine you have an electron whose mass of electron is 9.1 into 10 to the power minus 31 kg, and there is a u, correct, it is u, whose mass is say 60 kg. Now what we are going to do is, I am going to see what is the, if you are traveling in the form of a wave, you, it can be any of you, me, if we are traveling in the form of a wave, let us see what is the wavelength. So lambda equals h by mv, correct. So what is h? 6.626 into 10 to the power minus 34, and both of us are traveling at the same speed. Let us imagine both of you and me, you and electron are traveling with a velocity say 3 into 10 to the power 6 meter per second. Not possible, but still we are traveling, correct. So h by, what is mass? Mass of electron is 9.1 into 10 to the power minus 31 into velocity is 3 into 10 to the power 6, correct. Now similarly over here, 6.626 into 10 to the power minus 34 divided by mass 60 kg, right, this is kg, that is kg, into 3 into 10 to the power 6, correct. So this is lambda, this is lambda. So if you equate, even I have a calculator for you today, so we will make it very quick. 6.626 divided by 9.1 divided by 3 is equal to, how much I will get? I will get around 0.25 into 10 to the power minus 34, this is minus 40. So this would be minus 9 meter, correct, correct, no, minus 9, or you can also say minus 31 plus 6 gives minus 25, correct. When it goes up it becomes plus 25, minus 34 and plus minus 9, correct. So this is a nanometer. I can also write 0.25 nanometer, which is measurable. Nanoscales are measurable. Now let us see what is the wavelength created by me. 6.626 divided by 60 divided by 3 is equal to 0.037 into, when this goes up, 10 to the power minus 40 meter. That is, see how short it is. It means if my weight is 60 kg and if I am traveling in the speed of light, this is an example to understand what is the concept of matter wave, correct. why electron behaves as a wave. If I am traveling in the speed of light, just below that 10 to the power 6, 10 to the power 6, what would be the wavelength created by me? 10 to the power minus 40. Is it measurable? No. That's why even though they say any particle are traveling in the form of wave, the wavelength, the wave created by us will be very small. So they say this theory, even though it is applicable for macroscopic objects, macroscopic object does not travel in the form of wave because they have huge mass, and you cannot travel in the form of velocity of that one. I hope it is clear for you. You understood? So that clearly says wavelength of an electron is in the range that is measurable, and electron will travel in the form of wave. Macroscopic objects, no. Please write it down very quickly. That clearly explains that all subatomic particles, even if it is a proton, will travel in the form of wave. All subatomic particles whose mass is negligibly small, feather, if you take mass of feather, the wavelength will be slightly less. 60 kg can be converted into 1 milligram or as less. So as it goes more and more less, it will travel in the form of wave. Obviously, a feather doesn't travel in the speed of a light, I mean high speed. Okay, so that is an example. Now let's move on to the next concept. This is just an example. Now next one, Heisenberg's uncertainty principle. So first one was de Broglie equation that says that subatomic particles like electrons will travel in the form of waves, in the form of wave. Now next one, if they travel in the form of wave, imagine you have an electron. Imagine you have an electron inside an atom. Can you see the electron? No. Imagine you have microscope. You are trying to view. See, right until now, electron is not seen by any scientist. I'll explain you why. Electron is so small, its weight is 10 to the power minus 31. Forget protons and neutrons, which are very inside. They detected the presence, but seeing is really hard. Electron is usually what is that? Imagine I am having a microscope. So I want to see an electron. I want to measure the position. I want to measure the momentum of an electron. Exactly. I want to measure the exact velocity, exact momentum, exact position of an electron. I want to see where this guy is. Correct? Because Bohr said electron is revolving around the orbit. If something is revolving around the orbit, it should come back to the same position after some time. Like planet, we know after a year it is revolving around the sun. So after 1 year, where it will be, scientists know. Correct? Similarly, if electron is revolving around the nucleus in fixed orbit, after some time, if I stand there, okay, this guy, you might have seen in some movies, there will be some fighting scene and the hero will stand like this, and he know the villain will come back to the same place. Similarly, if I stand here, I know electron is possibly coming back. So thinking that I am seeing through a microscope, but electron is so small, so I am starting zooming. Some of you might have seen, correct? Zooming, I don't see anything, correct? So to zoom more, I can see only dark spaces. I will switch on the light. I forgot to switch on the light. Switch on the light. What is that? Light is also having a wave. Light is a wave. Electron is a wave. The moment I switch on the light wave will strike the electron. If I say, I think there is an electron. The moment I switch on the light, this wave will hit the electron. What will electron do? Electron will absorb energy and will move its position. Its momentum changes. So according to the new concept, it is impossible. How much ever you try under the sky, whatever technique you use, it is impossible to measure the exact position or exact velocity or exact momentum of an electron with entire certainty. You cannot be certain. You can be uncertain. It means in this region there is a probability of finding an electron, or this could be the region where I can see the electron. Not 100% sure, not accurate, not precise. I am uncertain, maybe or may not be. Similarly, velocity. This might be the velocity or this may not be the velocity. This might be the momentum or this may not be the momentum. You try to catch a feather. The best example I'll tell you. You try to catch a feather. Correct? When you try to catch a feather, the moment you take your hand like this, you are creating some force. air, in the air. With that force itself, feather is going somewhere. And think of an electron. There you are not trying to catch. Just this movement of your hand, obviously you can catch, no problem. This movement of your hand will create some force which will push the feather outside. Similarly, if light can excite and de-excite an electron, when you switch on the light, any light you take, low wavelength or low frequency, the light when it touches an electron, immediately it will change the position. Its momentum changes, velocity changes, mass remains same. Understood? Is it clear? Hence, according to Heisenberg, this guy complicates everything. Whatever we study now, everything is done. He said, how much ever you try, it is impossible to measure exactly and accurately the position and momentum of an electron. It means no one can see an electron. You can predict. Yes, in this region, there is a probability. Probability, that is a term you have to remember. Correct? There is a probability of an electron in this region. There is a probability that this would be the momentum of an electron. Exactly, no one can predict. That is known as really important. Please mark it. 2-mark question will come. I will tell you what to write. It is it is impossible to determine simultaneously and accurately. Simultaneously means if you try to measure momentum, position will change. If you try to measure the position, momentum will change. Because electron is traveling in the form of a wave, it has very less mass. Hence, it is impossible to determine simultaneously, simultaneously means at the same time, exact position, exact momentum or velocity of an electron. Please study it now itself. Repeat with me. It is impossible. What did I say? It is impossible to determine simultaneously and accurately the exact position and exact momentum of an electron. You cannot be certain about its velocity. You cannot be certain about its momentum. It is uncertain. Maybe it will be there. Maybe this will be the momentum. You cannot be certain. It is always uncertain because it is weightless, traveling in the velocity or traveling in high speed. Also, position keep on changing because its mass is very less. Correct? So, if they ask you for 2 mark, write this expression, write this equation, and there is an expression. Expression is delta x. I will tell you what is delta x into delta p greater than or equal to h by 4 pi. Now, don't ask me how did I get this equation. I told you there are certain things. Derivation of this equation is out of the scope of the material. We studied in degree or MSc. So, you do not need this, but you need only the equation. Understood? So, this is the equation where delta x, I will write here, well, delta x is equal to uncertainty, certain, exact, x. Uncertain means, delta x means in this region, uncertainty in position of an electron or any subatomic particle. Delta p, p stands for momentum. Uncertainty in momentum. We know that what is momentum? Mass into velocity. So, I can write delta x into delta mv greater than or equal to h by 4 pi. You have to write this expression. Mass is constant, mass is not going to change, mass is specific. Correct? So, I can take mass outside, delta x into m delta v, velocity changes, greater than or equal to h by 4 pi. So, this is one relation, put it in a box. This is another relation. So, what would be delta v? It's equal to uncertainty in velocity, m, mass of electron, if it is an electron. Correct? Is it clear? So, now utter confusion, whatever you studied, obviously you have to study. Detailed stuffs are there, but we cannot do that because out of the scope. But I will try to explain. I explained it. When you try to measure position, momentum changes. When you try to measure momentum, position changes. So exactly and accurately you cannot predict. So it is impossible to determine simultaneously and accurately exact position, exact mode. So you are uncertain. Uncertainty is delta x, uncertainty is delta p, greater than or equal to h by 4 pi. So keep in mind, don't write one more point. For numericals, they will ask numerical. For numerical, you can use this expression, delta x into delta p equals h by 4 pi, equals you can write, or delta x m delta v equals h by 4 pi. For numerical, you can use this expression. Please write it down fast. And don't hesitate, I am repeating again, ask your doubt. So it clearly shows now it is highly probability, it is highly impossible to measure the position and momentum of electron. I can say there is a probability. Now you have to use a new term known as probability. Probability means there is a probability that electron might come here. There is a probability this will be the position of electron. So now we are going into the concept of probability. But before going into it, I will take an example to show what happens if there is a macroscopic object and a microscopic object. Now significance of significance, I already told you, significance of Heisenberg uncertainty principle. It's like you are trying to view an electron to a microscope. You read NCERT, it is also there. Try to you try to view an electron, you are using a microscope. No, it is very dark. Microscope, it cannot zoom much, how much ever you try. So you switch on the light. The moment you switch on the light, you saw the wavelength of an electron when it is traveling with 10 to the power 6. It is almost same. So when the light strikes on an electron, immediately it will absorb very quick. We cannot see it. The moment you switch on light, it will happen very quickly, 10 to the power minus 8 second, very fraction of a second. Electron will change its position, electron will change its velocity, electron will change its momentum. You cannot be 100% sure that the electron is there. That is the significance of uncertainty principle. And you compare with you and electron. Light strikes on me. Am I changing my position? Obviously, if I change my position, that is not because of light. Light does not have that much power to change me. Because if I am moving, my wavelength is different than, my wavelength is large, we saw 10 to the power minus 40, if I am traveling with the velocity of light. So when light strikes on me, it just scatters or reflects, and my body is not absorbing light so that I can change position. But if there is some huge body, which is comparable to my energy, if there is a force that is comparable to my body energy, mass energy relationship, if it strikes me, obviously I have to change my position. You might have seen in movies, you will be looking at this, suddenly something comes, you blink and you open your eyes, that might be gone in a flash, Superman flash. That is different, but still understood. Now illustration of Heisenberg uncertainty principle by taking a mass of 1 milligram and an electron, correct. So I am taking an electron whose mass is 9.1 into 10 to the power minus 31 kg. Similarly, another particle whose mass is 1 milligram, that is 10 to the power minus 3 gram. Let us see the uncertainty. Delta x into delta v is equal to h by 4 pi m, correct. Here also h by 4 pi m. What is h? 6.626 into 10 to the power minus 34 divided by 4 into 3.14 into 9.1 into 10 to the power minus 31. Over here, delta x into delta v, uncertainty in both, is again 6.626 into 10 to the power minus 34 divided by 4 into 3.14 into 10 to the power minus 3, correct. This would be approximately, now we will neglect, or I'll use a calculator and I'll show you quickly. 6.626 divided by 4 divided by 3.14 divided by 9.1 is equal to 0.058 into 10 to the power minus 34. When it goes up 10 to the power plus 31, correct, it would be 10 to the power minus 3, or 5.8 into 10 to the power minus 5. Uncertainty in this, correct. Now, if you see over here, it would be 6.626 divided by 4 divided by 3.14, 6.626 divided by 4 divided by 3.14 is equal to 0.53 into 10 to the power minus 31. Understood? When 10 to the power minus 3 goes up 10 to the power plus 3. So, that is here uncertainty is very small. Uncertainty is small. What does it mean? If uncertainty is small, it is more certain. It means uncertainty in velocity or momentum, velocity and position of a particle. Imagine it is a feather whose weight is 1 milligram. It is certain, because if uncertainty is very less, it is more certain. But you see here uncertainty is large as compared to that. It is more uncertain. It means uncertainty in position and momentum is large. If one is known, other will be unknown. If one is known, other would be unknown. But here you see uncertainty is very less. If uncertainty is less, certainty is more. If mass increases, certainty increases. It can be certain this would be the position, this would be the momentum. If mass is less, uncertainty is more, certainty is less. Please note this down. Please write all these in your notebook, so it will be easy for your reference. There is no unit for this. We don't need to worry about unit here, because I have just taken an example to explain the uncertainty. Imagine both of them are uncertain, then one of them. Okay. Now, that is about uncertainty. Now, let's do some calculation. This is related to the concept that we discussed yesterday. Calculate the wave number of a longest wavelength. I hope you went through the concept yesterday. Calculate the wave number of the longest wavelength transition, the arrow, in the Balmer series of atomic hydrogen. Now, what are the hint? Calculate the wave number. So, I have to calculate wave number of the longest transition wavelength. I told you what is the longest. If wavelength is large, energy is less. They are inversely proportional. Balmer series. What is Balmer series? The value of N1 for Balmer series is 2. We have to calculate what is N2. Longest wavelength, shortest energy. The first transition of Balmer series, it is the shortest energy and longest wavelength, nearest one. Hence, the value of N2 will be equal to 3. Understood? If you remember Balmer series, 1, 2, 3, 4, correct? Balmer series is this and others, the one that is coming. So, this one is having shortest energy, this is having longest energy, highest energy. So, this will have shortest wavelength, but they have asked, that will have longest wavelength if energy is less. So, we got the value of N1, we got the value of N2. Wave number expression you have to write, really important, 109677 in you will get in per centimeter, 1 by N1 squared minus 1 by N2 squared, correct. Then 109677, what is N1 here? 2. So, 1 by 4 minus 1 by 9, correct, that is 109677. 9 minus 4 divided by 9 into 4. Use a calculator. Where is the calculator? you have to remember the unit, the one that I have used. Answer would be in per centimeter. Calculator says 9 minus 4, obviously it is 5, divided by 36, which is equal to something, correct. It would be 0.9677 divided by 0.14. So 109677 divided by 0.14 is equal to how much I will get? 783,407.1 per centimeter. Per centimeter. It can also be in per meter, no problem. I don't know what answer is given for you. One second, somewhere I did some mistake, I think. 109677 109677 yeah, correct, maybe number. Please note it down. So, this is the answer for this question. Okay. You can write also in meter, it into 10 to the power 2 per meter. Ah, my mistake. No, correct. Okay. Next one. If the velocity of the electron in Bohr's first orbit is 2.19, this is energy relation. If the velocity of an electron in Bohr's first orbit is 2.19 into 10 to the power 6, calculate the de Broglie wavelength associated with it. It means, you know, Bohr's orbit, first orbit, second orbit, third orbit. So there is an electron in the Bohr's first orbit which is traveling in the form of a wave, whose velocity is given as 2.19 into 10 to the power 6 meter per second. So there is an electron in the Bohr's first orbit, correct, around the nucleus, value of n equals 1, whose velocity is this. So I told you, when an electron is in orbit, revolving around the orbit, it will travel in the form of wave. It behaves as a matter wave. So if it is a matter wave, what it is wavelength? We have to calculate the wavelength, correct. Wavelength is given as h by m into v. We know mass of electron is, what is the mass of electron? 9.1 into 10 to the power minus 31 kg. Substitute. H is a Planck's constant, same h is 6.626 into 10 to the power minus 34 joule second, correct. Then 6.626 into 10 to the power minus 34 divided by mass 9.1 into, it's an electron, 10 to the power minus 31 into velocity 2.19 into 10 to the power 6. Let us see we have done it already. There is a calculator. 6.626 divided by 9.1 divided by 2.19, which will be equal to 0.332 into 10 to the power again 25 minus 9 meter, or 3, okay, we can write 0.332 nanometer, correct, that is also correct, or even you can write in picometer, it would be 332 picometer, it would be 332 picometer, it would be 332 picometer, correct. No, so I can write, see, I will tell you how to write 0.332 into 10 to the power minus 9 meter can also be written as 332 into 10 to the power minus 12 meter. This is in nanometer, this would be in picometer, so this would be equal to 332 picometer. So answer, this is the thing, answer can be in boards, no problem, answer should be correct, whether it is in nanometer or even in meter you can write, no problem, 332 picometer, or this is correct, this is also correct, 0.332, but answer should be correct, the decimals you have to be careful. So there is an electron in Bohr's first orbit traveling in the form of a wave, you have to calculate the wavelength of that particular electron, that is it, simple. So in normal, nanometer, picometer, okay. Next question, calculate the wavelength of an object of mass 0.1 kg, object, see the mass is high, moving with a velocity of 30 meter per second. Now again we have to calculate wavelength whose of an object of mass 0.1 kg, SI, everything you use in SI, moving in the velocity of, what is the velocity given, 30 meter per second. H we know, lambda, first you write the equation, you will get 1 mark, H by mv, wavelength and velocity, wavelength mass means you have to use this relation, correct, which is equal to 6.626 into 10 to the power minus 34 divided by mass 0.1 into velocity 30, calculate. (6.626) divided by 0.1 divided by 30, 2.208. 2.208 into 10 to the power, there is nothing, minus 34 wavelength meter, you see, just see the wavelength, it is very small. So if even even if it is traveling with a speed of 30 meter per second, even its mass is very less, its wavelength will be very less, which you cannot calculate. It means for macroscopic object, for large mass object, even though we cannot say we are traveling in the form of matter wave, we are just a matter, but when you go for very subatomic particle whose mass is very large, then you can say it is traveling in the form of wave. Please notice down. So this is how, so it is clearly seen that when mass increases, wavelength decreases. So this is an unmeasurable wavelength, you cannot measure this wavelength. So it is a concept which tries to go above your head, but try to understand theory. A lot of basics are there which we don't need to go in detail. Another question is, the mass of an electron is 9 we know it, again they are saying mass of an electron is 9.1 into 10 to the power minus 31 kg. If kinetic energy usually important for your CET competitive exam, we have included it, 3 into 10 to the power minus 25 joule, calculate its wavelength. Kinetic energy, if velocity is small, correct, mass is small, velocity is whatever, kinetic energy will be very small. Now this is a relation that equates kinetic energy and wavelength. So, equation is lambda equals h by square root of 2 m into kinetic energy, correct. Now, mass of electron 9.1 into 10 to the power minus 31 kg, kinetic energy of the moving particle, what is that? 3 into 10 to the power minus 25 joules. Substitute 6.626 into 10 to the power minus 34 divided by square root of, what is the value of 2 itself, into mass 9.1 into 10 to the power minus 31 into kinetic energy 3 into 10 to the power minus 25. Here you will get, even if you do not write in board like this, no problem, divided by, we will see what we will get. Two into 9.1 into 3 is equal to, correct, 7.39 into minus 39.25, correct, minus 56 into minus 28, correct, again divide 6.626 divided by 7.39 is equal to 0.89 into 896 or 89, yeah, 897 into minus 28, when it goes up it becomes plus 28, plus 28 is minus 6 meter, correct, or I can write 897 into 10 to the power minus 9 meter, which is equal to 897 nanometer. Yeah, here they have given, I will just write it, I will give what is given in your material itself, so it won't be confusing. 896 into 10 to the power minus 6 meter. So, it can be in nanometer. If I am writing in nanometer, it becomes 896.6 nanometer, or I can also write 8966 angstrom. I hope all of you know what is angstrom. Angstrom is 10 to the power minus 10. So, I am taking 3 over here, then it becomes 10 to the power minus 9 nanometer. If I am taking 1 more over here, 10 to the power minus 10 angstrom. So, please try to see, I will tell you one thing, if you are very perfect in these numericals which are in your study material, which is already taken from NCERT, correct. So, you will be perfect in your boards plus your CET competitive exam, do not worry, easily, even for NEET also this time that much easy questions were there, do not worry, this time is easy, next time it will be hard, nothing like that, it would be easy. Be perfect with NCERT and you be perfect with your study material first, all the things are included. Some things are avoided because that would be taught in your level 2 class, but in this in this topic all the concepts are included. Okay. Now, last questions related to Heisenberg uncertainty principle, that would also be asked numerical. Calculate the uncertainty in momentum of an electron. If they use the term uncertainty, obviously it is related to Heisenberg principle, Heisenberg uncertainty principle. In the momentum of an electron, if the uncertainty in position is plus 0.002 nanometer, uncertainty in position is given. So, here we have to calculate uncertainty in momentum, where uncertainty in position is given. What is uncertainty in position? Plus or minus 0.002 means not there, not here, in between. So, you can just write 0.002 nanometer or 0.002 into 10 to the power minus 9 meter. Within this range, 10 to the power understood. So, that is uncertainty. According to Heisenberg uncertainty principle, you write the equation h by 4 pi. When you write the numerical, you can use equals instead of greater than or equal to. So, therefore, delta P equals h by 4 pi m 6.626 into 10 to the power minus 34 divided by 4 into 3.14 into mass. It's electron, right? Of an electron, we know the mass of electron, 9.1 into 10 to the power minus 31. What would be the answer? Calculator, 6.626 divided by 4 divided by 3.14 divided by 9.1 6.626 divided by 4 there is a mistake. I forgot to put it's not that, sorry, my mistake, it's 4 pi, thinking what, delta x, right? This is delta x. So here the value of delta x is 4 into 3.14 into 0.002 into 10 to the power minus 9, my mistake, sorry. So now we will calculate it. 6.626 divided by 4.626 divided by 4 divided by 3.14 divided by 0.002, that would give me 263.77. So we will make it as 263.77 into 10 to the power minus 7, it goes up, it becomes plus 9 it becomes minus 25, correct. This would be the uncertainty in position. What is the unit of position? Sorry, momentum. Momentum is mass into velocity. Mass is kg meter per second. Correct. You can write in your study material, they have given 2.63 into 10 to the power minus 23. That is also correct. No problem. So these are the things related to quantum mechanical model. In the next session, we will be discussing about quantum mechanical model and more significant things. Please, just if you have time, read NCERT once, the one that is going to be taken in the next session. Just read it so that you will be able to understand the concept more and more. So these are the numericals. We study de Broglie equation, really important. Matter wave, concept of matter wave equation. Heisenberg uncertainty principle, really important, related to your boards, and also ASE, and couple of numericals related to. So I am taking the numerical immediately after the chapter concept, so you will be able to understand it more. So please note it down. I wish you all a nice day, and I'll see you, not see you, you can see me in the next session. Enjoy your day. Thank you.